Okay, so I'm back. So now let's talk about why silver iodide works and what it actually does. Okay, so first of all, the actual chemical composition for silver iodide is AgI. This is silver, and the I is iodide, silver iodide. It's backwards. I tried to write that so you guys could see it clearly. But anyways, it's AgI. That's silver iodide. Now, why does it actually work? Because its composition resembles ice and not the immigration kind. So bear with me here. Both ice and silver iodide have a crystal lattice, and the crystal lattice in silver iodide is this. AgI, Ag, I, Ag, I, Ag, I, Ag. Do you see something here? Do you notice this pattern? Because I've been noticing it in the snow that's frozen on my windshield. In fact, I've actually been videotaping and photographing the snow because it actually all looks identical and it has a different formation. I don't know if any of you have noticed that, but this is basically the crystal lattice of silver iodide. We'll get to the crystal ice, actual water, in a moment. But let's talk about this for a second. So in cold clouds, water can remain liquid even in freezing temperatures, and actually well below freezing temperatures. So why do they use silver iodide? Because silver iodide provides the nucleus that allows that liquid water to freeze. And let's just say the cloud wanted to freeze, even though I'm sure clouds know exactly what they want to do. Basically, the cloud seeding plane emit silver iodide into the air through these trails, and the ice nucleus attaches to the liquid water below freezing, and it forms snow and ice because it provides the actual nucleus to do so. So once the silver iodide is introduced into the ultra cold liquid water, the water droplets freeze onto this. They freeze onto this. Ice crystals form. They collide and aggregate, and they become heavy, and eventually they fall as snow. Now, it's important to note that silver iodide does not produce moisture. It only reorganizes water into existing precipitation. Now, you might be wondering, well, how does it reorganize water? Well, I'm going to show you. Now, let's just take a look at what ice looks like in its molecular level, shall we? And you're actually going to just be so amazed at this, because this is just another example of God, really. So, oh look, a snowflake. This is the molecular structure of ice, which literally resembles a snowflake. I mean, this drawing isn't the best, but if I were to redraw it without looking at the camera and drawing it, dun, 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 dun. Oh, look, it almost looks like a star. Can you see the difference? How one almost looks like an hourglass with a point. I sort of call this the nanoparticle shape, and this looks like a star, a snowflake. This is silver iodide. This is the molecular composition of ice. Okay, Let's move on, shall we? Now, we know that water molecules are V-shaped. So when they lock into ice crystal formation, it's because they have frozen. So water is a V-shape, and then when frozen, it crystallizes into this hexagonal shape that literally is like the shape of a snowflake or a star. Yes, that's six-sided snowflake geometry that is unimitable and unduplicable. Yes, both words I just made up. If you notice, and don't look at my drawing, but absolutely equal spacing, the hexagonal symmetry, and the surfaces are more stable for water to attach to it. Okay, so maybe this diagram, actually these ones should go in like this more, but okay. This is the distance in the atoms in silver iodide. Obviously not really, because this is a drawing, but this geometry allows water to snap on it as if the silver iodide was ice. So how does this happen? Basically, when silver iodide enters a super cooled cloud, so the water droplets are already below freezing, it's still ultra cooled liquid water, it's desperately unstable. The water droplets encounter the silver iodide, much like we are attracted to narcissistic relationships, and we attach ourselves to them. Oh, look, a freezing template. Let me just attach myself to that. And there you go. And although they do say that the silver iodide cannot force the freezing, it cannot add water, and it cannot cool the cloud. Nonetheless, they need the silver iodide and temperatures below freezing because, believe it or not, water will stay in liquid form at -10. And this is because in clouds, they are literally like microns, like micro droplets. And so they are able to stay at ultra cool temperatures without freezing. So is this making you question your entire childhood with snow? So basically, before the seeding, the cloud will contain these tiny, tiny, tiny droplets of ultra-cooled water. They could be anywhere from -5 to -20 technically, although they say the ideal temperature is -5 to -15 for cloud seeding. And then the silver iodide is introduced because it contains a nucleus that the water then attaches itself to, and voila. The liquid droplets will freeze onto them because it's literally acting as a catalyst for that reaction to happen. And then the ice crystals grow rapidly. Stay tuned for the next video because I'm going to talk about what temperatures are required to produce rain and why cloud seeding may not be the most ethical way to navigate our earthly changes.